Hello everyone, my name is Emason Munene, a researcher at the Center for Data Science and Artificial Intelligence, DSAIL, here at Dedan Kimathi University of Technology, DKUT, in Nyeri, Kenya. And today I'm going to be demonstrating a part of the work here at DSAIL in Bioacoustics. The aim of the project is to provide a way of monitoring the health of ecosystems using bird sounds. And we have made progressive efforts, and today we're going to be demonstrating what we have. And here we have the prototype of what we've been working on. It's made up of several parts. So one, we have the PyWild, which is a power management board developed here locally at DSAIL. Its main aim is power management on the second part, which is the Raspberry Pi. This is the brains of the system that is used to do what I shall be showing in a few moments. And connected to that is a battery that is used to power the system. As you can see, this is not connected to the mains and is only powered by the cell. So because we are in a lab setup, the powering is done by the battery. But in the field, we have a port for the solar, and therefore it's able to charge and keep running for some time offline. So from there, I'm going to be demonstrating the program that runs on this board and how it will be useful in conservation efforts. So here I'm operating on my local computer, and the first thing will be to SSH to the Pi board that is here. And so here we are SSHing, pressing the password, and now we've gotten into the Pi, the computer itself, the Pi. So in here we have several folders. I'll go into the patch folder where we have the code that we will be running. The first thing is to activate the environment. And once we have the environment up and running, we will run a script. So what this script does is it will be running real-time inference. So the aim is to be able to collect bird sounds, and by collecting bird sounds, we'll be able to detect which birds are those. And by collecting both the sound and the analysis of which bird that is, that information will be helpful in determining the health of the forest. So the main part of this demonstration is to be able to show the ability of the board running offline without any internet connection to detect different kinds of birds. So already the system is up and running. It's listening to the mic, and I'm going to show an example by running a few audios on my phone on YouTube. So I've collected a few samples here and there. The first one is a woodland kingfisher, and we are going to observe the Pi running the detection. So here's a bird sound. And as you can see, it mentions there, it's a woodland kingfisher. First it said red-throated, but as you can see subsequent, it says a woodland kingfisher. And what you're seeing here is real time and it's offline. So the model is running on the Pi. So an instance is when it's out there in the wild, it will hear such bird sounds, and when it receives the sounds, it runs the detection and it's able to note down, hey, there's a woodland kingfisher that has been detected in the forest. Just a few more examples, maybe some that are common to us. The common bulbul, which is quite known here in Kenya, the common bulbul. So based on that sound, you can see on the screen that it's able to detect it's the common bulbul that is dark-capped. And the model is quite good on several fronts. So with this demonstration, we show that it's possible to have offline, on-edge inference of bird sounds, and from that being able to assess the health and the condition of forests in conservation efforts. This is a key milestone because oftentimes it requires someone to be out in the field to manually collect the audio and come back to the lab and do inferencing on it. But In this, we have both the recording and the inference at the same time, real time. This hastens or increases the amount of work that can be done because there's no need for the loop of going to the field, collecting and coming back to the lab on it. So this is our progress on the project for bioacoustics, and we hope that in future we are going to see further advancements on the same. Thank you.